the concept of average velocity. In order to understand average velocity, we must understand the displacement. Okay, so let's understand displacement. Okay, displacement is defined as the change in position vector. So I'm drawing a graph. Okay, so let's say this is the origin, this is origin or the start point. Okay, start point, and let at time ti the initial position vector is ri. Okay, vector, and let at time tf the final position vector be rf vector. Okay, so this is the final, this is final position vector, and this is initial position vector. So the difference of final position vector and initial position vector. So I'm writing in this way, the difference of final and initial position vector is given by delta r vector. Okay, so this quantity is called displacement. Okay, so I'm writing over here delta r vector. This represent displacement of particle or object in time delta t. Okay, so this symbol is called delta and it represent change, okay, in quantity. So this is to be noted. Okay, so we have this, so delta t equals tf minus ti. Therefore average velocity, okay, so we denote it by this symbol v average, average velocity. So this equals displacement vector, okay, delta r vector by delta t, and we know displacement vector can be written as the difference in or change in position vector. So we can write final position vector minus initial position vector, and delta t equals tf minus ti. So this expression gives the mathematical form of average velocity. So I'm rewriting, okay, this expression in this way. So we have this. So what we can conclude is that average velocity, okay, is the product of vector, that is displacement vector, okay, and positive, okay. We know time, okay, delta t. This is scalar, okay, time, and delta t is always, okay, delta t is always positive, okay. We take time as positive quantity and time is scalar, okay. This is to be noted, okay, and positive scalar, that is inverse of time. So we have this. Now let us discuss this, okay. If you look into this expression, okay, so what we find on right hand side, okay, we have a vector, okay, we have a vector times 1 by delta t, okay. So we have what? Scalar, okay. This is 1 by scalar. So if you look into this expression, clear, we have this. Now multiplying, so if we multiply vector by a positive scalar, let's say the scalar is positive, okay. So if we multiplying vector by positive, okay, scalar, and if the scalar is not 1, okay, let's say the value of scalar is not 1, okay, then what we find? Changes only the magnitude, okay, only the magnitude, only the magnitude of vector, not its direction, okay. This is to be noted. Now next, okay, multiplying, let's say the scalar is negative, okay. So multiplying vector by negative scalar, and let the scalar is not -1, okay. So if the scalar is not -1, then what we find? Changes the magnitude, okay, changes the magnitude as well as what? The direction, okay, changes the magnitude of vector and reverse its direction. So we find this, and as I said earlier, okay, time, so in this expression delta t, okay, is always, this is a scalar and is always positive. So therefore we can conclude that direction, okay, of average velocity, okay, since this is always positive, okay, this is positive quantity, okay, and is scalar, okay. Therefore direction of average velocity is along the direction, okay, it is along the direction of displacement vector, direction of displacement vector. So this is to be noted.